please tune into our feed on Delta Lake LinkedIn channel as well as Delta Lake YouTube channel, because those are two channels we are streaming from. Would love to know where the folks are rolling in from. So let's see. Meanwhile, looks like cool. I am joining from San Francisco, and Jacek, you?
Warsaw.
Oh, pretty cool. Pretty cool.
Yep.
Nice.
Poland.
Let's see. Poland, how is it there?
Yeah. Oh, yeah. Weather is quite nice. It's not sunny as it was a couple of days ago, but still temperatures is just okay.
That's
Getting
pretty
better
cool.
every day.
Getting better, right? Yes, as we
Yep.
move into more of like cool days of summer, I guess.
Yeah. What's the
Awesome.
temperature in San Francisco? It's probably
It's
13 degrees of Celsius.
yeah, probably
Yeah.
right around there. Yeah. So a quick reminder for those who are joining and new to the session, we launched a 3-part series on Delta Lake 1.2. And today is the time for our module 3. We have awesome Jacek on the call who is delivering this workshop. So without further ado, Jacek, why don't you take it away and welcome everyone to the Delta Lake 1.2 tutorial 3.
Thank you, Vinny, for this short, concise introduction. I'm hoping that my presentation of Delta Lake is going to be very similar. There are lots to cover, yet I'm going to go over quickly everything I wish I want to cover today, because, past presentations weren't that successful as I wanted, meaning time-wise, not content-wise. Okay, welcome all to this last module 3. I'm here with Vinny to present the coolest, latest features of Delta Lake 1.2. It's gonna be tutorial, but I'm not giving you much time to, do all these things I'm showing you. Sorry for this. We've got only 1 hour. I'm very talkative these days. So, fear not, all what I'm gonna present today during this presentation is gonna be available on my GitHub, and Vinny and the team at Databricks will surely let you know where to find all we covered today. Okay, so Delta Lake SQL. So the agenda. There are 3 parts in this agenda for this module 3. Among them is Delta Lake SQL. There is also time travel and transaction log fundamentals. We'll get to them, but let me start with Delta Lake SQL, because looks like I'm getting more and more how to say, not familiar, but also acquainted, and also I'm getting how to say, a hang of how to use SQL, and to be honest, I'm loving it. It's not only about how SQL is supported by Delta Lake, but about SQL expressiveness in general. Okay, so Delta SQL. So again, this is part 3 of our Delta Lake 1.2 tutorial. Everything is in this repository. Although this particular notebook is not yet there, because I've been shaping it up to deliver the best content available. So I'm gonna upload it right after the session. Okay, so learning resources. Let's skip it, and disclaimer. This is exactly what I started explaining in my 4 introductory minutes. So lately, I've been a huge fan of SQL and environments like Databricks. The reason being is that, after years claiming I can be a Scala, earlier Java developer, I eventually think I'm slowly giving up on this thought, on this idea, because, I love coding, but still it takes so much time. And if I can use something more succinct, more expressive like SQL, why not to do so, right? So, and since Delta Lake, my beloved environment, I love hanging out with and in supports SQL, why would I waste my time on doing something I can express easily and quickly using SQL? That's the disclaimer. Okay, so yeah, this is my testimony to my alteration, and this pun is wholeheartedly intended. Why? Because you will see that alter command in Delta Lake conveys or gives us some cool features that are available in the latest and greatest of Delta Lake version 1.2. We'll get to it. So, environment. We are in a notebook environment provided by Databricks. And to my great surprise, whenever I run this IO Delta version command inside this environment, I'm surprised that they are giving us 110 as the version of Delta Lake, even though, yeah, I hear ya, we've got Delta Lake 1.2.1 already out, and that this version may look odd, but fear not, every feature that's part of Delta Lake 1.2.1 open source version is covered by this environment as well. No idea why they have this difference anyway. I'm spending too much time on it. So know that I'm in Databricks, and by default, the default data format in this environment is Delta already. So whatever command I'm gonna execute, or you are going to execute in this environment, without specifying what data source you are interested in, will end up using Delta data source. So whether you need it or not, you will be using it without specifying any other data source supported by Spark/Databricks. So just to set the stage. Okay, so this is our agenda, and this agenda covers Delta Lake SQL, something that this notebook is all about. Then we touch base on time travel, something that we've already covered during our previous sessions, as well as transaction log fundamentals. Again, something that we've already covered, yet it's always nice to remind you about why these features are so cool and available in Delta Lake, what made them possible. And this is basically all about transaction log. And to be honest, it was when I was preparing myself for this presentation, when I fully realized why understanding transaction log makes you really understand the features provided by Delta Lake. Without transaction log, all these cool features wouldn't be possible. So yeah, we'll be discussing transaction log quite a lot. Okay, so let me start very basic, and let's start with create table. Why do I need create table? Well, I need a table, right? I need to create my table. I'm gonna base all my commands on. So this is just a very basic create table, something that's already supported by Spark, so nothing out of ordinary, something that's already supported by Spark / Databricks with or without Delta Lake. So let me run it just to make sure that this command finishes up perfectly fine, and it did. So, okay, now I'm going to use very first table, Delta Lake 101, using Parquet data source. And the reason for using Parquet is just to introduce you gently into the SQL space of Delta Lake by showing you the very first command, which is convert to Delta. And for this to be demoed fine, I need Parquet table. That's this create table SQL command is for. So let me run it. And after just a couple of seconds, 1.5, I get this table. So let me describe it. Bang. And you've got your 3-column, 1 partition Parquet table. It's registered in a catalog in Metastore. So it's accessible. It's available from Spark SQL only environment like Databricks, and it has nothing to do with Delta Lake. Okay, just so you know that what I'm showing has nothing to do with Delta Lake still. Okay, Okay, so as I said, the above SQL commands are just standard and supported by none other than Spark SQL itself, and perhaps other SQL-aware environments. So time for something that's Delta Lake specific. And the very first command that you may or may not have used in the past for Delta Lake is just to convert to Delta. And this convert to Delta is very Delta specific SQL command supported specifically for Parquet tables that may be converted to Delta Lake format for something that's coming for the other commands and for the other features that we'll be discussing during this session. So convert to Delta is very basic, very simple, very simple. It just convert to Delta. You specify your table name, and then you may or may not specify how this table is partitioned by. And honestly, this is my very first time when I'm using convert to Delta with this partition by clause. And I was kind of surprised by why do I need to specify partition by clause since this Delta 101 Parquet table is already described by this partition by clause when I was creating this table. I cannot explain it. I need to dig deeper and learn more about why this command needs it. But for the time being, just know that even though this Parquet table is already partitioned by month, I need to specify it to create a partitioned Delta table. Perhaps I do not have to do this. I don't know. Okay, but anyway, I'll do it just to make sure that it's gonna work. So yeah, it went perfectly fine, and my very first Delta Lake table was created based on existing Parquet table, and that's the information that's the first takeaway of the session, that you can convert any existing Parquet tables into this Delta format. And the only difference between Parquet table versus Delta table after this convert to Delta is just very single directory for transaction log. Okay, so there is this description in official documentation of Delta Lake where they say to revert converting Parquet table to Delta table is just a matter of removing this directory called delta_log. It's probably here. Oh, it's here. You see? So just delete this directory and you should be fine. You are where you were at this Parquet table before converting it to Delta. Nice. Okay, so we've got this. And next, Delta specific command. So we just learned about one. This is convert to Delta. Now we've got another one, describe detail. So describe detail describes Delta table in more details. Okay, so let me do this and let's see what we get. So we end up with just one row that describes this table, and it shows that this is Delta table with this ID, with this name. Description wasn't specified. That's the reason for this null. Okay, weird looking, but still. Location for my catalog table is here created, and some other metadata related information like number of files, partition columns. And that's the reason why you might be surprised to see that Spark SQL, after you convert this Parquet table to Delta, you will see very few information about Delta table in Spark SQL owned catalog, because all this information that's needed by Spark SQL / Delta Lake is written now as part of this transaction log. Okay, so now after we created this very first version of our Delta Lake table, let me use and let me show you the third SQL command that's very Delta specific, called describe history. Describe history will show you the history behind your Delta table. So let me execute it and see that there is only one single version of this Delta table, version 0. It was just created and by myself, and that was this operation called convert to Delta. And there are some other operation parameters, other columns, job, notebook, something that was added quite recently. I think it was part of 1.2 release 2, is this engine info, something that's that gives you information about who created this table. So for this Databricks environment, it's going to be Databricks runtime, while for open source Delta Lake, it's going to be just Delta Lake 121 / Apache Spark. Okay. And again, just to make sure, just to set the stage for this collaboration, for this presentation, every feature I am showing you, I'm gonna show you, and I've been showing up to this point, is found as part of Delta Lake open source 1.2.1. Okay, there'll be only one cell that I'll specifically that I'll be using for something that's very Databricks specific, but just one out of 82 cells that I'm gonna present you. And this is just to show you something that will eventually be part of Delta Lake once Databricks and the Delta Lake team decide to open source it. Okay, so this is this describe history. And up to this point, we covered 3 commands, well, as a matter of fact, 4 SQL commands. They were create table, convert to Delta, describe detail, and the last but not least, describe history. Out of these 4 SQL commands, 3 are very Delta specific. They are convert to Delta, to convert Parquet table into Delta format, describe detail, and describe history. Okay, at this point, I wanted to ask you, do you have any questions? But given that this is only 1 hour presentation, I'll spare you this question. And if you've got any questions, just leave them in this Q&A window or wherever you join us from, and let us know what question you have. Slack will do fine too. Okay, let's talk about DML commands. Okay, again, I'm shall I say SQL convert. I'm pretty new to this SQL only space where all I have is SQL. I'm more Scala / Java / Python dev, more dev than SQL only data engineer. And that's why all these acronyms, even though I know them, DML and DDL and blah, 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 whatever starts from D these days. Anyway, so all these acronyms are well known in SQL space. But if you are not familiar with this DML acronym, it stands for Data Manipulation Language. Okay, and this is something that I found out just today. This is part of some bigger space than SQL only, and this is, as Wikipedia put it, it's just computer programming language. Nice, didn't know it. Used for adding, inserting, deleting, and modifying, updating data in a database. Okay, and that's what caught my attention. That was kind of surprising to me while preparing myself for this presentation, is that something that I didn't know is that a DML is often a sub-language of a broader database language such as SQL, with this DML comprising some of the operators in the language. So I didn't know that DML is more broadly used outside SQL. Well, now you know it too, if you didn't. Okay, so DML is basically a term to denote three, to be honest, three SQL commands. They are insert, update, and delete. I allowed myself to add yet another merge command, because merge is something that we'll be discussing as part of this data manipulation language, because it's just a merge or just a composition of insert and update. So you can just use merge to do insert and update at once, which is pretty cool, huh? So we've got four SQL commands that are part of data manipulation language, being part of Delta Lake SQL. So let me present them to you. So just before I present you with all these DML statements, just know that Spark SQL comes with a limited support for the above DML commands. With that being said, I mean, they are supported by Spark SQL, but for two of them, as a matter of fact, three of them, Spark SQL will end up with exceptions unless you use a DML compatible data source like Delta Lake. Okay, there are others that give support or bring support for update, delete, and merge. Just know that if you use standalone vanilla Spark SQL environment, you may run into some exceptions due to not having DML compatible data source like Delta Lake, okay? Except this insert into, which is supported by Spark SQL out of the box. And by saying supported, I mean executed and ended up with some, data source changed rows, so to say, okay, rather than exception. So let me start with insert. Insert is indeed supported by Spark SQL with and without Delta Lake, but know that if you are running a Spark SQL environment with Delta Lake installed, like this notebook in Databricks, you will get extra features not available in Spark SQL itself, which is time travel, which we'll be discussing in a sec, as well as some other features. Okay, so what is insert all about? It's about inserting a new row to existing table. So insert into table name Delta Lake 101 and the values that I'm willing to insert into this table. So let me execute it, and that gives us these metrics like num affected rows and num inserted rows, as well as a brand new version of our table. And for this, we've got second version of our table, version 1. We are starting from 0. That's why we've got this second version 1. And yeah, that we started with convert. Now we have this Delta Lake table to be available after this operation called write. Okay, and it was mode append and some other operation parameters that you may or may not be interested in for example, reporting purposes. There's also information about what notebook you may have used for this version and some other information. Okay, so this is describe history. And as you can see, we have this insert into command tracked by history, as well as convert to Delta. So now you know that these two commands are tracked by or are recorded by Delta Lake in this in history space, and this is part of transaction log. And you can use describe history, yet another Delta specific command to just query this history and see what versions you work with or you can work with. Okay, and something that caught my attention while preparing myself for this presentation. As a matter of fact, it was something that struck me back then when I started spending, or shall I say, hanging out with SQL more often. It was like with all this succinctness of SQL, I'm surprised they didn't come up with something more succinct than more clever, so to say, than select star from table. And it was this thought, this thinking was triggered by this Databricks environment, because probably more so, because Databricks, this environment, this notebook environment, provides two ways for programmers to query your tables in a more human-friendly way, in a sense that there is display method and display function. So Scala and Python have got this extra support from this notebook environment of Databricks, while for SQL, I wish we could have something like display table, whatever. Okay, anyway, I'm just saying you my thoughts, sharing what I found really cool in Delta Lake, in SQL, and not so much. So yeah, this is just a very basic select star from Delta 101, and you get this 2-row data set. Okay, so this table, after convert to Delta, we ended up with just 1 row. Then we inserted one extra second row, and now we've got 2 rows. And we're just showing all these 2 rows just by using select star from Delta 101. That's very basic SQL. Not so very basic is this update. You may have used this command, SQL command, in other environments, more relational than Spark SQL. Just know that by default, Spark SQL does not support update. Unless I'm mistaken, I don't think so, but anyway, unless I'm mistaken, update will end up with exception saying that support for update is partial in Spark SQL. That's why you need DML update aware environment like Delta Lake. And together with Delta Lake, Spark SQL will happily support update. Okay, let me show you. So remember, we had 2-row data set with ID 0 and 1, with these IDs in the English words 1 and 0. In this partition month 1.1, this is just for some fun, but honestly, I am not going to use it that often. Then yeah, I'll have to rethink all the demos to just leverage that this partition, this table is partitioned by month. Okay, anyway, so update SQL command, and I'm using update table name, setting name 1_update, just to denote that this row was touched by this command, where ID equals 1. So remember, we had 2 rows, 0 and 0, and 1 and 1. After this column, we'll have, again, 2-row data set. But this time, not only we ended up with yet another version, but also this command show us that it was that easy to update Spark SQL / Delta Lake owned table, and something that would not have been possible unless you installed Delta Lake. Okay, so Spark SQL, again, to my understanding, would not have supported or does not support it out of the box. It just gives us very foundational support, very basic support for just parsing this SQL command update, but that's all. Okay, so, execution is left to implementations like Delta Lake, and Delta Lake is happily supporting this update, but just by just providing yet another version of our table. And now you see that we've got convert, write, and update operations leading to have 3 versions of this Delta table. Okay, so we've got it, and then delete. Okay, so yet another command in this DML statements out of this DML statements, and this delete is very basic, very intuitive, shall I say? And this is just delete from table name where IDs for this particular example are greater than 0. And you know that there is only one record that matches this predicate, and this is this ID 1. So yeah, so let me execute it. We get back metrics of this operation, of this command. So number of affected rows is 1, exactly what we expected. So let me see, the history, and now you see that this led to create yet another version. This time, this is after a delete, and querying this table using select star from Delta 101 gives us exactly what we expected. So you see, the purpose of this presentation / demo is to show you that in this distributed large data set focused Spark SQL environment, you can execute something that was not previously available before Delta Lake or Delta Lake-like environments appeared on the market. So one of the many features why you'd want to consider Delta Lake as part of your Spark environment are exactly the commands that I showed you that leads you from one version to another to the version you want to work with eventually. And yeah, so given your use cases, you may or may not need delete, update, insert support, but definitely there are other commands that I'm sure that will give you some deep thinking about why you are not yet using Delta Lake or Delta Lake-like environments in your Spark applications. Given it's very basic, it's just minus package, and you've got this Delta Lake installed, and that's basically it. Okay, so after you deleted this one record, so let me show you. So we started from this 2 record data set, and after delete, we ended up with just one record data set. So the recent version of your table, of your Delta table, contains just ID 0, just one record. And this is the moment when suddenly your phone starts ringing wildly, and you've got this idea that it may have been somehow connected, associated with, or because of your recent changes. Now, you badly need and you beg for something that would revert all your changes back to the version that worked just fine for your end users. Ladies and gentlemen, this is exactly when Delta Lake comes with restore support and give you this restoration, if I may put it this way, reverting changes support for free, because, well, we are speaking about Delta Lake 1.2 open source version. So it's just a matter of pulling it from Maven repo via packages, and you're done. You've got this support out of the box. Oh, well, kind of like out of the box. So for free, definitely. So this is, ladies and gentlemen, restore SQL command. Yet another Delta Lake specific command. So Delta Lake 1.2, a part of Delta Lake 1.2 was support for reverting changes back to the version you want. Okay, and given that we already have quite a few versions, now we can revert our delete to version 2, 1, or perhaps even to 0, to the initial state of our Delta table. Okay, so how to do this? Let me start with describing history. Okay, so we've got 3 versions, nice. And just by using restore table name, Delta Lake 101, to version as of, and you specify your version 0, 1, 2, or perhaps even 3. Not sure what's going to happen if you select the version that you are currently at. You feel free to give it a try. Well, what I'm going to use for this demo, I'm going to just revert just this single delete operation. Okay. And I can do this by version as of a clause of this restore table, as well as timestamp as of, and providing with this timestamp value to specify the version of Delta Lake table of yours before this delete operation. So let me do this. Hop. And yes, you're right. If you thought that's gonna create yet another version in our history of this Delta Lake table, you're right. So describe history, and now you see that yes, we ended up with yet another version 4 after this restore operation. But not only this, we also got the state of our table that was before delete, which is exactly as if we reverted all the changes made by or introduced by delete. So we are back at update state. And ta-da! Yeah, that just worked. So this is part of something that's called in the wild time travel. So in Delta Lake parlance, if I may put it this way, or space, you may have heard about time travel, and revert just is one of the few ways, or shall I say, couple of ways, how you can revert your changes, or just have a look, have a peek at what was available back then. So this history tracking is exactly the, and this transaction log is exactly for the purpose of restore, to look at what files constitute a previous version, and just restore the files that are stored along the other files that belong to other versions. So yes, you're right. We will be seeing disk usage growing up every version of this Delta Lake table. You're right. We'll get to it. But, well, for the time being, there is no other way to do this time travel. But keeping track and keeping track of all the files and these files themselves to be available for this restore and other commands. Okay, so merge. Other SQL command that's supported by Delta Lake is merge. And as I already mentioned, merge is basically a unification, shall I say, merge of 2 other commands that I've already introduced, which are update and insert. So you've seen update and insert already. Now it's time to see what's cool about merge. Merge is basically one-time operation yes, shall I say, transactional operation that will create yet another version in our history, or in the history of this Delta Lake table. Basically, sparing your time, or no, allowing you to execute insert and update in a more succinct way, SQL-like succinctness. Is exactly in the realm of this merge command. And again, merge as well as update and delete is one of these commands that are only partially supported by vanilla Spark SQL environments. So if you are using a vanilla Spark SQL installation, you will end up with merge throwing an exception, telling you that you need something like Delta Lake package to be installed to have full support for merge. Okay, but since we are in Delta Lake away environment of Databricks, we've got it for free. So select star from Delta Lake 101. Okay, and this is just 2-row data set. Now, merge into looks like this. It uses a table name that you can alias for much better identifier that you can use on this join-like on clause that will join two tables. The one, let's call it target, and the other, let's call it source. For this, for the purpose of the demo, I call this table updates, and I joined these two tables. Yeah, perhaps I should be using something more table-like. But I'm very happy to finally grab this values clause, and I am using it perhaps too often than I really should. So values is just a shortcut to create a table of these 2 rows with these 3 columns called ID, name, and month, which not surprisingly are the same as the one I'm updating these rows to by using merge into. So I'm merging these 2 tables on this ID column, and what I'm saying, hey, merge, whenever you find matched rows, update by name column in this target data set with whatever is in target already, plus merge. And for this, I am using standard function that's provided by Spark SQL concat, just to show you that whatever was part of target name already, for rows that match this merge into, or that match, is gonna have this extra suffix merge, while whatever hasn't been found in the target table is inserted right in, and will end up with, well, let's see. We started with ID 0 and 1, and we're matching on IDs. So since we are using this updates table with 2 rows and only 1 row matches of this updates table with target by ID 1, we will end up with 3-row data set with this 2 merged 2 inserted right directly, while for 1 we'll get this concat standard function executed, and we'll see merge as part of this 1_update name. Let's give it a shot. So as you can see, I am not going to say that this merge into is simple, but definitely can replace insert and update commands that you may have been using in the past. So now you know that with Delta Lake, you get this extra support for merge into, which is a just unification combination of insert and union. And after executing this merge into, you ended up with this Delta 101 table with 3 rows, exactly what we expected, with this one row ID equals 1, with name updated with this underscore merge prefix. Prefix or suffix, if I'm not mistaken. Sorry for confusing you. Anyway, it just proves my point that merge worked as expected. Nice. And the last but not least, know that merge is transactional in a sense that it will lead to yet another version of the Delta table you merged into. And yeah, if you don't like what you see, you can always restore to previous version. Okay, so now you see 6 versions, starting from convert through write, update, delete, restore, ending with merge. Nice, right? And it was, just all is available from just pure SQL environment without doing any heavy coding that you probably would have to do if using Scala or Python or Java. And that's one of the many reasons why people, let me put it this way, almost hates Spark SQL / Delta Lake because it can be so succinct that it does not allow for much coding, if at all. And that was one of the many reasons why I started looking into this SQL heavy direction, where whatever I could just type using Scala or Python or Java, I can just type much faster using SQL, provided this environment is SQL aware, just like this notebook environment of Databricks. Okay, so we talked a little bit about all these commands supported by Delta Lake. Now let me switch a little bit to switch topic to time travel, which is yet another topic of our module 3, discussing the latest and greatest of Delta Lake 1.2.1. So time travel, what it is. Time travel is basically moving back and forth between versions that are tracked by this transaction log of Delta Lake. So Delta Lake, whenever there is a transactional command, will store metadata about previous versions and current version, basically about versions of your Delta tables, and allowing you for basically time travel. So, which is basically similar to what you've already experienced with this restore command. But there is more to this. Restore will restore previous version of your Delta table, making it the current version. So whenever you do select star from table name, you will always query the latest and greatest of your Delta table. While time travel allows you to move between versions without changing history or the notion of the current version. Okay, but just know that this you can query all the snapshot of a Delta table, something that you can learn more in this official Delta Lake documentation, but know that there is more to it. And this is the only cell where I'm mentioning something that's very Databricks specific. This is select version as of. It is not available yet in Delta Lake open source. So it's only available in Databricks. So sorry for not showing you select version as of in Delta Lake open source, but I'm pretty sure that they'll eventually open source it, given all the other more cool features that are available part of open source. So I'm a strong believer that everything that's part of Delta Lake within this Databricks owned environment is will soon be part of open source Delta Lake. But nothing is lost though. because you can always revert to use Python, Scala, or Java. So for this particular case, if you wanted to move between versions without changing what's at the tip of your history, so-called the latest version of your table, you basically you can basically use version as of or timestamp as of options in your batch or streaming queries. So it's as simple as doing, let me show you all the versions first, as doing this. For this, I'm using Scala, but feel free to use Python or Java. And the difference between what you may have used in vanilla Spark SQL environments is this option version as of that's provided by Delta Lake. And this is the qualifier of the version that you are interested in by version, but you can also use timestamp as of and use timestamp instead. So Spark read option will give you the version of table that was available as version at version 3. So let me display Delta Lake Delta 101 as it was at version 3, and it contained just one row. Just to prove that this is available in Databricks using select star from Delta 101. I'm just showing you this SQL variant. And if I'm not mistaken, Databricks is waiting for a Spark SQL release that would support version as of extensions to select. That's the only limitation they are facing, if I'm not mistaken, to provide you with this version as of. And if you, and again, if you skip this version as of or timestamp as of, you can always access the latest and greatest of your Delta table. So without this qualifier, without this clause version as of, timestamp as of, you always end up with the latest and greatest of your Delta table. But Delta Lake gives you this clause, and you can just move back and forth between versions and perhaps do some CDC, what's called this column, change data capture like functionality for free. Okay, so let me run it. And you see, so just by using this, I got version 3 of my table, skipping this clause, and I ended up with just what's available as the latest and greatest of this Delta table. Okay, there are other comments. There are other comments supported by Delta Lake that are not available in Spark SQL only environments. And these commands are generate, to generate some meta information for other environments to query Delta tables. There is also optimize and vacuum. I skip generate. It's not as interesting as the other two. So let me touch base on optimize quickly. We are left with 6 minutes. Oh man, again, I was quick and I haven't digressed so often yet. Looks like we are running out of time very quickly. Okay, so optimize. Optimize is just one of these two cool optimizations available in Delta Lake. This is bin packing. Another Z-order based optimization is coming. Will be released soon. Hopefully by Data AI Summit in San Francisco in 2 weeks. Finger crossed. And so this is optimize command that's already available in Delta Lake open source 1.2 that will optimize your Delta table by the size of your files, making them basically bigger and at the same time more optimized for reading. So let me execute this optimize table command on our table. And after executing this optimize table command, I'll get this matrix showing me that the number of files added is 1, number of files removed is 2, and there are other statistics that you may be interested in. Just know that this optimize will create yet another version of our Delta table, and this version will end up marked as optimize operation. And so now we have a 7th version, given that we are starting with 0. Nice. And I can also use optimize based on a partition column that will make this optimize command slightly faster, because it's limited to this partition, to the files for this partition only. And this is the only the only cell that I use a partition column in. So yeah, so just showing that this is available. But given that I already executed optimize and this Delta table is already optimized, we ended up with no files being added or removed. And there was this is kind of that was kind of surprising to me, and because surprised me because I was expecting another optimize operation, but it looks like they optimized optimize command. So when there are no files added or removed, there is no point marking this operation as part of this transaction log, which makes sense. Now you know it too. The last command is vacuum. Vacuum stands for cleaning up, or serves allows you to remove files that are no longer in use or needed, giving you giving you more disk space, because files get deleted physically, and mind that you won't be able to time travel to the version that you just vacuumed. So if you are as aggressive as 1 hour, well, before executing vacuum, I highly recommend using dry run. That will show you how many files are going to be touched by this operation. For this particular case, 1 hour is not enough to cover any file we just created, because 1 hour is exactly the time span of our presentation. So our query returned no result. So let me execute something that will allow me to go below a certain threshold. And as a matter of fact, it was already active, because otherwise I would not have been able to execute this 1 hour. But this, just know that this setting is just how Delta Lake prevents incidental removals, file removals. And now I'm gonna specify that I'm interested in vacuuming files that were created just 0,001 hours ago. And as you can see, there are quite a few files to be removed, quite a few, meaning 4 to be exact. And now I'm executing it without this dry run. And that basically will remove files that belong to, that are part of previous versions. So though the history will show me historical history with versions like 0, 1, 2, 3, and 4, and others, now you know that files that are 0,001 hour old are simply not available, because, well, I physically removed them, vacuumed them. So this restore Delta 101 to version as of 1 or even 2, 3 will lead to Spark exception, because, well, we just use this very time aggressive vacuum. The last but not least is to mention alter table, which is seemingly not very powerful command in general, but so powerful in Delta Lake. Quite recently, I discovered many cool features of Delta Lake 1.2. Among them are table constraints, as well as column mapping and generated columns. And all these cool features are available because of this alter table supported by provided by Spark SQL with some extra enhancements of Delta Lake. So Spark SQL together with Delta Lake gives you this nice three features of Delta Lake 1.2 called table constraints to constrain what you can insert, merge, update to your table, as well as column mapping for virtual renames, as well as something that will be generated at runtime, unless you provided the values for these generated columns. Lots to cover. Sorry, we ran out of time, so cannot cover. I just briefly touched base on these cool features. If you need me or someone else to cover these features, talk to me, Vinny, Danny, Databricks in general, and let them know that you are interested. And we probably will at some point provide you with another demo, another workshop-like session where you can learn these cool features in this nice interactive environment. That's pretty much it. Any questions?
That was awesome, Jacek.
Yeah.
There are a few questions in the chat, and I think Sam, thank you a lot for being engaged throughout the session. If you are not already a part of Delta Lake Slack channel, please join the Slack channel. I'll paste a link here to join because you have some amazing questions. I'm pretty sure we are not able to get through it, but we will be happy to answer it over there. Yeah. But Jacek, do you have any parting thoughts? I know we ran over time a little bit.
No, well, don't provoke me to spend another hour to talk about Delta Lake. I can do this easily. So no thoughts, no closing thoughts, except we're done.
This is awesome.
And by the way, Vinny, you probably are going to join Data AI Summit in San Francisco in person, correct? I'll be there too.
Correct.
So yeah. So
yes,
yeah. So
and we have some Delta Lake events, and can't wait to have you there, Jacek. I think that will be the first time I will ever meet you in person.
Yeah, me too. Meeting you in person. So
Awesome.
can't wait, definitely. And this is the extra information for others. If you are wondering, should you join, this event organized by Databricks in person, do so and meet us and discuss, all things Delta Lake in person with Vinny, Danny, and other, Delta Lake committers and team, and myself too.
Exactly. Yeah. And, if you cannot join in person, you can also join virtually. Of course, in person, you get to meet all the contributors and
Yes.
Have fun. Delta Lake community. It's fun.
Yes.
Exactly. Yeah. Cool. I think some people asked about the Slack channel link. So let me ping that real quick before we end. I'll put it in the chat so everybody has access to it. All right. There you go. Awesome. Well, this was great. So Jacek, I can't wait to have a new series with you, whether it be like after summit or, something along those lines. So, and thank you all who tuned in to all these modules. Really excited about it. And hope to see you in the in another series or in the Spark Summit or, Yeah.
Thank you all. Thank you, Vinny.
Bye.
Ciao. Bye.
Ciao.